This video, I'm going to solve two questions, one that obeys the theorem and one that does not. So let's start by understanding what do we mean by the mean value theorem for derivatives. Suppose that if we have a function which is y is equal to f of x is continuous at every point of the enclosed interval of a and b. So this function is considered to be continuous over the interval of a and b. Okay, and is differentiable at every point of its interior with an open interval, which is a to b. Then there is at least one point C between a and b at which the instantaneous rate of change equals the mean rate of change. That in the interval of a of b, there will be one point which is C in the interval of a and b at which the instantaneous rate of change is equal to the mean rate of change. So this is the mean value theorem, which takes the form of f of b minus bf of a divided by b minus a. So after we understood what is the mean value theorem, we are going to solve two questions, one that obeys the mean value theorem and one that does not, with the help of the Casio graphical calculator. So let's start by the first question, which is stated by f of x is equal to x to the power of 1/3, that is continuous on the interval of -1 till 1. So the first question, we need to state whether or not the function satisfied the hypothesis of the mean value theorem on the given interval, and if it does, find the value of c in the interval of a of b that satisfies the equation. So to find if this function satisfies the theorem, we need to look first if the function is continuous through this interval. And as we can see that the f of x is a cubic function, and all cubic functions are continuous throughout their domain. We can state A, first of all, the function is continuous over its domain, or if we can simplify it more and state it perfectly, will be through the interval. The first condition is satisfied as the function is continuous over the interval. To check if the function also satisfies the mean value theorem, we need to differentiate the function of f of x and see if the function of f of prime of x will satisfy the interval. So B, we need to find f prime of x. Okay? F prime of x, we need to differentiate this function. In order to differentiate, we use the power rule. So, according to the power rule, we need to drop what is in the power add the x here, then doing 1 minus 3 minus 1 in order to know what's the new power. Okay, so you get 1 over 3 x to the power of negative. The way of writing this form is to change it to radicals, which is 1 divided by 3 into the cubic root of x, in which x is squared. So as we can see from the derivative, that x cannot be 0, so x cannot be 0. So the function of f prime of x, or the derivative of f of x, is continuous over all of its domain except 0. As we know that we can't have 0 in the denominator, because a 0 in the denominator gives the function a problem. So this function, as the derivative of this function of f prime of x, is not differentiable as x cannot equal to 0. Therefore, the function does not obey or satisfies the mean value theorem. Let's go to the second question. F of x is equal to x squared plus 2x minus 1 over the interval from 0 to 1 included. So, to check if the function satisfies or obeys the mean value theorem, first of all we need to check if the function is continuous over this interval. So, because f of x is a polynomial function, then every polynomial function is known to be continuous over its domain, specifically continuous over the interval from 0 to 1. Let's see now the second condition. We need to look at if the function is differentiable over this interval without any. So the second condition, we need to check the derivative of f of x and see if f of x is differentiable over the interval from 0 to 1, which is excluded, without any asymptotes in between. So let us derive the function of f of x, which is 2 of x plus 2. As we can see, that the derivative of the function is also a polynomial. So a polynomial function is known to be also continuous over all of its domain. Specifically, in this question, we look at that it's differentiable over the interval from 0 to 1, which is excluded. Because the function of f of x obeys both conditions, then we are going to find what is the rate of change or the mean rate of change. So to find the value of c, we need to do f prime of c, which is equal to f of b minus f of a, divided by b minus a. So we can put the intervals here, in which we can write f of 1 minus f of 0 divided by 1 minus 0. And here I can write 1 squared plus 2 multiplied by 1 minus 1 minus 0 squared plus 2 multiplied by 0 minus 1. Okay? In which the whole thing is divided by 1 minus 0. So 1 squared is a 1 plus 2, which is 3, minus 1 is a 2. Then 0 plus another 0 is 0, and a negative with a negative gives me a positive 1. So 2 plus 1 is 3, which is divided by 1 minus 0, which is a 1. So f prime of c is equal to 3. But as we can see that f prime of c is the same as f prime of x. So I can replace the f prime of c by the derivative and replacing every x by a c. So this one could be written as 2c plus 2 equals to 3. I can take the 2 here and I solve it as 2c, which is equal to 3 minus 2 is actually a 1, which is divided by 2, where c is half. So c is the midpoint that exists between the interval of 0 and 1. In this video, we explained what is the mean value theorem and what are the two conditions that satisfies the mean value theorem. We solved two questions, one that does not obey the mean value theorem and one that obeyed the mean value theorem. So here, the final statement will be that the function of f of x obeyed the mean value theorem.